What we're doing is we're looking at double replacement reactions and how to complete those reactions. And for a tool to do that, we're borrowing from our lab that we're going to be doing in a couple of days. And this lab sheet actually looks like this. There we go. Actually looks like this when it's all together. Okay? And as we go back to where we're going to see that we just need this row right here. So this row right here is what we're doing in the exercise that I've asked you to do for homework, and 2 with 3 gets mixed right here. 2 going down to the bottom of the sheet is iron chloride, and 3 is aluminum sulfate. So when we go over here, the thing that is different, let me pick up an arrow here, copy, and go back over here, there we go. So these guys up here are these guys written as ions. So you can see what their charge is in the chemical equation for the molecule. It's kind of an equation. It should just be the way that these guys are balanced together. There has to be 1 of these and 3 of these because we crisscross their charges. So when I take the 1 from the chloride, that tells me I have 1 iron. When I take the 3 from the iron, that tells me I have 3 chlorides. Now these are given to you, but I'm going through this anyway to reinforce what I'm trying to help you understand. So here, this 3 plus on the aluminum is meaning that we have to have 3 sulfates, and the 2 minus on the sulfate ion is telling you that we have to have 2 aluminums. So that's what I mean by the crisscross. Now, let's go to the other side. We know that we're going to have this iron right here, right? It has to be on the other side. So let's go ahead and put our iron in right over here.
So I should write down this.
Oh yeah, you want to write this down. And then I'm going to take the other cation, which is the positive ions, and I'm going to put the cation for aluminum sulfate over here, which is aluminum. And now we're going to go over and pick up the chloride. Now chloride isn't staying with iron. Okay, this is double replacement. And so he has to come over here. And we're going to have to figure out what our subscripts are, which is what we'll do next. The double replacement, again, means that we have 1 partnership here and another partnership here. And what happens is the anions, these positive dudes, or negative dudes, I'm sorry, the negative dudes get switched. Okay, the chloride goes with the aluminum, the sulfate goes with the chloride, goes where the iron is, and displaces the chloride. So over here, chloride is with the aluminum, and then iron is picking up the sulfate. Now, these charges aren't going to change on these ions, so they're the same charge on the other side. Iron is still a 3 plus, aluminum is still a 3 plus, and let's get these down a little bit so we can do our crisscross arrows. And then the sulfate is a 2 minus, and chloride is a 1 minus, just like they were up here. Okay, the charges are exactly the same down here. Okay, so let's go ahead and balance these guys. What we've done is we need to balance our molecules first, the molecules on the right side, and once we've done that, then we can balance the equation. So, iron is going to be a crisscross of the charges of iron and sulfate. So, the 2 is going to go here, and the 3 is going to go here. And so, iron is going to be a subscript of 2. Sulfate is going to need a parenthesis around it, and it will have a subscript of 3. It's just that easy. It is, really. But it takes a little introduction. And I've been explaining this in a different way for the last 10 years. This is the way I finally came up with today, which is, I think, a really nice way. It works. It makes so much sense. So here we're going to do the same thing. We're going to crisscross the charges, and aluminum has no subscript because his subscript is 1. And chloride is going to have a subscript of 3. And now we have balanced the molecules. Does that make sense?
A little bit. So, yeah. But how do I set it up the data?
You're not doing any data on the recording sheet right now.
Oh.
All you're doing is these equations. You have that sheet in your possession, and we are talking, for those of you watching the video, we're talking about, not this guy, come on, let's get there. We're talking about this dude right here. Okay, this is the sheet that you'll use during the lab. Why do you have this? Because you need this list of chemicals, so you know what's with what. And you need this part because you know who is getting mixed in row 2. That was the assignment, was row 2. So here we're mixing 2 with 3, then we're going to mix 2 with 4, then we're going to mix 2 with 5, and that happens as we go all the way over till 12.
So tonight we're going to do that
all 11 of them, right. There's 11 of those to do. Okay? So, now that we have this much, now we're going to balance the equation. So, let's look at iron. How many on the left? On the right?
2.
Good. So, let's make this 2 so that we have 2 irons. But remember the coefficient that I just wrote right here. This coefficient multiplies not only the iron, but it also multiplies the chloride. So, I'm just going to go now and get my irons balanced. So let's do the iron over here, which we don't have to do at all. Let's do the chlorides next. How many on the left?
1.
How many chlorides?
3.
3. Okay. Times 2. 2 times, yeah, you got it. 2 times 3 equals 6. And so to get 6 over here, we need a 2, don't we?
Yeah. Why did you multiply them?
Because the coefficient multiplies the subscripts of every atom in the molecule.
Oh,
okay. Okay? Good. You learned something today, didn't you?
Yeah.
Yeah, that's good. Okay. Now let's go on and let's take the aluminum. On the left we have how many?
Yeah.
How many?
Oh, 6.
No, aluminums.
2.
2. Okay. So we have 2 aluminums on the left because of this subscript. And over here we have 2 aluminums because of the coefficient. Okay, so aluminums are good. Now, sulfates, how many do we have on the left?
4.
4 is the oxygens that we have in the sulfate ion. Now you got to think of this as a little beastie. And that little beastie is all together. You can't take him apart. It's like pulling arms and legs off of people. It's not nice. Okay, so that means we have 3 beasties. Okay, so how many beasties do we have over here on sulfates? 3. We're balanced. Now we can go back and put in 1s for everything that we didn't need coefficients for. Now, what I want you all to do is work the second one while I'm helping Susie, and we'll check you out. Okay? Okay, let's try the second one now. Here we have iron chloride with hydrochloric acid. So in this one, we are going to be looking at charges on the iron and the chloride, just like we had up here. In fact, your first molecule in all of your homework tonight is going to be this iron 3 chloride. So all it is going to change is this second guy. Okay? In this case, we're doing hydrochloric acid now. So let's go ahead and get it started on the other side by putting our cations over there. And the first cation is going to be the iron, and the second one will be the hydrogen. Now, we have to switch partners, but guess what? we got the same guys. The anions for both this guy and this guy are the same guys. So when we put these over here, they've got to have the same subscripts. Okay, and Cl on the second guy here, the hydrochloric acid, is going to be a 1 because we are going to have exactly the same ratios that we had over here. So what we do is, since they're the same thing on both sides, the ratios are 1 to 1 to 1 to 1. When you have a ratio of 1 to 1 to 1 to 1, you have NR stands for no reaction. Nothing's going to happen there. Let's go back up to the first one because I didn't classify that. That is a double replacement reaction. Okay, double replacement because we have two sets of partners. Okay, we got this partnership here and this partnership here. And on the other side, we have two sets of partners, but the anions were switched. And that's the only difference. Okay, let's go down and do the third one. And that's as much as I want to put on this video right now. So let's look at iron 3 chloride. Same guys up here, just like before, but this time we were manganese sulfate. Manganese is a transition element, and so I have to get his charge based on the sulfate charge, which I know. I don't know manganese because he's a transition element down in the valley. So here we go. Sulfate is a 2 minus. Manganese has to be a 2 plus. Can't be anything else. So what are we going to do on the other side? Let's take a look. We're going to put in our manganese again. Okay, so manganese is going to come in over here, and the iron is going to come in over here. And now we're going to switch partners. So the sulfate is going to come over here with the iron, and the chloride is going to come over here with the sulfate. Or, well, I'm sorry, with the manganese. Yeah, this guy's manganese. Sulfate is over here. So we got iron and chloride. Now, just like we did in the first one, we want to crisscross our charges. So iron is a 3 plus, so we'll put him underneath iron. Sulfate is a 2 minus, so we'll put him under sulfate. Manganese is a 2 plus, and chloride is a 1 minus. And you can see that we've got the same numbers down here that we had over there on the left for the individual ions. Now, let's go ahead and do a little crisscross, and we will balance our molecules. So the 2 goes to the iron, and the 3 goes to the sulfate, which is going to require a parenthesis. And so we put our 3 here outside the parenthesis, and the 2 becomes the subscript to the iron, and we are good with iron and sulfate. Now manganese and chloride, when we crisscross, we're going to have it like this, and the manganese has no subscript, and the chloride will have a subscript of 2. And now we have balanced our products, and because the products are balanced, we can go ahead and balance the entire equation. So we'll start with iron on the left. We see here as we look at iron on the left, he has no subscript, so he's a 1, but he's got two irons over here. So back over here, I have to put a 2 to give me 2 irons. And let's go to the chlorides. I have 3 here, but I only have 2 here. So to get the right numbers, we're going to have to multiply this guy's coefficient by 3, or by 2, I'm sorry. No, by 3. We're going to have to multiply them by 3 or 2. What I'm going to do is use this subscript to multiply whatever we have over here. Now that 2 has to be multiplied by a 3 to give 6. And this 3 is going to multiply my chloride over here to get 6 there. Now that's something a little bit new that we haven't done before, except with other types of reactions in double replacement. But by crisscrossing this guy with this guy and using it for coefficients, we can achieve the same thing we did in other places. Now we're going to go and get our manganese. Manganese right now has a coefficient of 6 in front of him, so we've got to have a 6 over here on this manganese, which gives us 6 sulfates. And to get 6 sulfates on this side, we've got to multiply this guy by 3, and that gives us 6 sulfates, because 3 times, whoops, 2, I'm sorry. Got to multiply this guy by 2, and that gives us 6 sulfates. Now what I did, we balanced this equation okay, and the ratio came out 6, 6, 2, 6. That's this 6, this 2, this 6, and this 6. But because that can all be divided by 2, and we come up with the same ratio, the actual ratio is going to be 2, 3, 1, and 3, which is essentially crossing these guys out and putting in a 3, cross this out, put it a 1, cross this, whoops, no, not to cross that out, but cross this guy out, make it 3, cross this guy out, and make it 2, as it was originally. So, if you get off track like I just did, and you wind up with everything able to be divided by 2 or 3 or any number, and they all come out even, that means you can reduce that ratio and get what I have here. And that's it, folks. I hope this gets you going. And let's label the kind of reaction we have here. And this guy is a double replacement. And that's it. Thanks for watching.